Morning once again. So we can start with our session. Let me just remind you about the important dates. I sent those important dates on Blackboard. However, there are students who are saying that on the 20th of April 2022, they will be writing a test. So I just decided that we can just shift that one quiz 2 on the 20th to be on the 22nd of April. So that means the quiz that you were supposed to write on the 20th, you're going to write it on the 22nd, which is Friday. So I think that one is you have to take note of that. Number 2, quiz number 3, you're going to write it on the 26th of the same month of April 2022. So I think the scope for those two quizzes can be chapter 2, 3, 4, 5. Remember, those chapters are connected. So you can't say because we did autocorrelation function in chapter 1, so we can't be able to use it in maybe chapter 5 or 4. So that means those chapters are connected. So it's very important to start from chapter 2 going forward. So, but if you have some challenges, you will let me know, then we take it from there. But I suggest that chapter 2, 3, 4, and 5 has to be covered on quiz 2 and quiz 3. But if by that time we have already covered chapter 6, is going to be included. Okay. So do you have any question about the important dates? So quiz number 2 is on the 22nd of April 2022. Quiz 3 is on the 26th of the same month, April 2022. So please note that. And remember, on Thursday, you are going to write your first test. Yes?
Sir,
Yeah.
so is quiz 3 going to act as an optional quiz?
Yeah, it's what we've agreed, isn't it? I said you are going to write 3 quizzes, but I will take the best 2. If you don't want to write the third one, so that means I'm going to take the first 2 quizzes.
Okay, thank you, sir.
Okay. So now we can continue. Mm, okay. Just open my window journal. There we are. Um, lecture number 21. Let me remind you that I showed you the formulas on how to calculate the variance of the estimated mean, and I showed you 2 important formulas. The one that you can apply when you have been given the moving average process, and the one that you can use when you are given the autoregressive processes. So those 2 formulas, you can use them to calculate the variance of the estimated mean. Variance of the estimated mean, to remind you, is the var of x bar. That is the variance of the estimated mean. I said this is equivalent to the gamma of 0 divided by n, 1 plus 2, 1 minus k over n, rho k, isn't it? If you still recall. And I said this formula, you can use it only if you have been given what? The moving average process. So you can use this one when you have been given the what? The moving average process. In other words, to calculate the variance of the estimated mean when you have been given the moving average process, this is the formula that you have to consider. That's number one. Number two, you can use the same formula var x bar, which is equal to gamma 0 over n, 1 plus 2. Oh, sorry, there is a summation here. K equal to 1 up to n minus 1. Sorry for that. Yeah. The first one is var of the estimated mean, which is equal to gamma 0 over n, open brackets, 1 plus 2, the summation of 1 minus k over n, close brackets, where k starting from 1 up to n minus 1, rho k. That is the formula that you can use when the process is a moving average. However, if the process is autoregressive process, if the process is autoregressive, you can use var of x bar, which is equal to gamma 0 over n, open brackets, 1 plus 2, the summation of k equal to 1 up to infinity of rho k. So this one, you can use it if the autoregressive process is given. Okay. So this is what I've introduced some times back. Now, if you want to calculate the confidence interval for the mean, let's say calculating the confidence interval, which is CI, for the mean. So when you want to calculate the confidence interval for the mean, you use this formula. The mean x of n plus or minus z alpha over 2 times the square root of var of x bar. So this is the formula that you can use to calculate the confidence interval for the mean. But if the process is a moving average, so var of x bar is going to be represented by the first formula, this one. Okay. And if the autoregressive process is given, var of x bar is going to be indicated by the second formula there. So what we're trying to say is that this can also be equal to x bar n plus or minus z alpha over 2 times the square root of square root of gamma 0, the square root of gamma 0 over n, open brackets, 1 plus 2 summation k equal to 1 of n minus 1, 1 minus k over n rho k close brackets. If the process is what? It's a moving average process. So you're going to have such formula to calculate the confidence interval. Are we together? So remember, this one now is when the autoregressive is given. Okay. But, it's when the moving average, sorry. It's when the moving average is given. Sorry for that. It's when the moving average is given. Okay. Now, if the autoregressive process is given, so x bar plus or minus z alpha over 2 times the square root of r of x bar is going to be given by. So can I use the next page? Can I go to the next page, please?
Yes, sir.
Okay. Therefore, so x n bar plus or minus z alpha over 2 times the square root of r of x bar can also be equal to x n bar plus or minus z alpha over 2 times the square root of gamma 0 over n in brackets 1 plus 2 summation k equal to 1 up to infinity of rho k close brackets. Okay, so in this regard, it's when the autoregressive process is given. So you're going to use this one. Okay. But if rho k is equal to 0, so var of x bar will be equal to gamma 0 over n. So if rho k is equal to 0, var of x bar, you can say x bar n is equal to gamma 0 over n. Therefore, this implies that xn bar plus or minus z alpha over 2 times var of x bar now will be equivalent to what? X bar n plus or minus z alpha over 2 times the square root of gamma 0 over n. That is when rho k equal to 0. So you can just use this formula to calculate the confidence interval for the mean. Are we together? So those are the things that I wanted to introduce. So now, if there are no questions, we can just go to the example. Do you have any question before we go to the
Sir,
example?
sir.
Yes.
The
Yes.
question is that when we are calculating these parameters and also the confidence, do we interpret in the end or we just give the answers only?
You're going to interpret at the end. I'm going to show you. Isn't that you're so fast to ask a question? We're going to do example where I'm going to show you how to interpret the solutions. So you have to interpret at the end. So I will show you how do you interpret those things. Any question? So in the absence of any question, let's go to example 5.4.1, page 41 on your lecture notes. Page 41, example 5.4.1. Okay. It says, suppose that in a sample size of 100, in other words, you have been given a sample size n equal to 100. Okay. From the autoregressive of order 1, given sample size of 100 from xt equal to phi 1 xt minus 1 plus zt. Okay, where zt is a white noise with mean mu. Okay, and what? And variance 2, and variance sigma squared z, which is equal to 2. Okay, so they give you the variance of 2 there. Okay, and then the parameter phi 1 is equal to 0.6. Okay, and the sample mean x bar n, which is x bar hundreds, is equal to 0.271. So those are the information that are
Sir,
given. Yes,
where does this sample mean come from?
the sample mean come from.
Where does it come from?
It's a given information. It's a given information. Remember, they gave you a data with a sample size of 100. That is coming from the time series process, which is the autoregressive of order 1. And then you have been told that Z is a white noise with mean mu and variance sigma squared. And phi 1 is given by 0.6. And the mean is the mean of a sample. They calculated the sample there. They found that the mean is equal to 0.27. It's coming from the data in simple answer. Do you get that?
Right, sir.
Yes. So now there is this information. Now the question says, construct an approximately 95% confidence interval for the mean. So we just want to construct the confidence interval, 95% confidence interval. That's number one. So how do we do that? I gave you a formula, so you have to check whether the process is what? It's autoregressive or moving average. So, but we realize that it's a what? It's a autoregressive, and it's autoregressive of order 1. So which formula are you going to use? Obvious, you're going to use this one. Okay. To construct the confidence interval, you're going to use this formula up there. Okay. But before you do that, you are supposed to calculate the autocovariance at leg 0, which is gamma 0. You have to calculate gamma 0, this one. You have to calculate that one first. Then later, you calculate the autocorrelation functions at leg k, which is this one. Okay. So can you please calculate? I think we did this one before. Can you please tell me what is gamma 0? What is gamma 0? So you have to calculate gamma 0 there from autoregressive of order 1, and I know you know how to calculate it. So, but in my case, I just need the answer. What is gamma 0? So I'm looking for gamma 0. Anyone? What is the value of gamma 0? Guys, are you telling me that you don't know how to find gamma 0? And we did this example or this exercise before. Anyone who can assist us? There's none. Oh, you're still calculating? Guys, are you still there? Anyone? Are you still there?
It's sigma squared over 1 minus psi 1 squared.
Sigma squared z over
1 minus psi 1 squared. Then you must substitute the value of sigma squared
I
there
think
and
okay.
the pi because it's
Yeah.
given.
So this is later we're going to substitute the s. So this is gamma 0. Gamma 0 is equal to sigma squared z divided by 1 minus phi 1 squared. But we have been told that sigma squared z is equal to 2. This is the one. Okay? And then phi 1 is equal to 0.6. So you can substitute there and find the answer. Just do that and find the answer for me. You got it? What is the answer?
3.125.
3.125. Yeah, correct.
125.
Come again?
125.
I can just hear 125.
It's 3.125, sir.
Okay, thank you. 3.125. Okay, let's put it here. 3.21 125.
125.
Okay. 125. Okay. Now let me just go to the next page. So our gamma 0 is 3.125. Now what about gamma 1? But that one we are going to substitute it later. So let's just go to this formula here. Try to substitute and see. Or yeah, just find the var of x bar then. Yes. Find the var of x bar. So that means you have to find the var of x bar or x bar is the same thing. Okay, and remember you're going to use gamma 0 over n, and gamma 0 now you have it, you can substitute here. It's 3.125 divided by n, 1 plus 2, okay, summation of that 1 to infinity of rho k. Okay, so which is equal to what? 3,125 divided by n open brackets 1 plus 2. We are summing them up to infinity, so it's like what? Rho 1 plus rho 2 plus rho 3 up to what? Up to infinity, isn't it? Then close the bracket. So the question will be, what is rho 1, what is rho 2, what is rho 3? Rho 1 is equal to what? Anyone? You can just use 5 before we substitute anyway, if that one is going to be easier for you. So I think if I still recall, this is the same as 2. This one is going to be phi 1 plus phi 1 squared plus phi 1 cubed, ne? Plus phi 1 cube, and so on. Is it correct? And again, remember from geometric series, if it's like this, you have to find sum of infinity, which is equal to a over what? 1 minus r. You still remember this one? And your a is what? It's phi 1, isn't it? Divided by 1 minus, what is a ratio? Ratio, this divided by this is phi 1, this divided by this is phi 1. So it's phi 1, isn't it? So now, so this can also be equal to 3.125 divided by n open brackets 1 plus 2 open brackets what? Phi 1 divided by 1 minus phi 1. Okay, then you close the bracket, isn't it? So which is equal to what? 3.125, sorry, divided by n open brackets. So it's equal to what? It's 1 minus phi 1 plus 2 phi 2 plus 2 phi 1, sorry, phi 1, isn't it? Then you divide by what? 1 minus phi 1. Is it correct? I think so. Then it's equivalent to what? So 3,125 divided by n. This one and this one, so we are going to have 1 plus phi 1 divided by 1 minus phi 1. Isn't it? Yes. Now we can substitute phi1. So it's going to be 3.125 divided by, remember, even n is what? It's equal to 100. So you can divide by 100 there. Open brackets. 1 plus 0, 0.6. Is it 0.6? You refer 1 minus 0.6. Then you can tell me the final answer there. I'm waiting for the answer.
0.125.
0.125, yes, it's correct. So therefore, var of x bar is equal
So
to
can you check on the
0.1.
slide?
Then you are done with that. And remember, we just want to find the confidence interval then. Using this formula. Using this one. Okay. So x bar n plus or minus z alpha over 2 times the square root of what? 0.125 is equal to what? So can you please find z alpha over 2 for me? Find z alpha. I just want to see whether you still remember how to find it. Find z
Sir,
alpha.
can you go back? I didn't take
Okay.
the screenshot.
And that one? Yeah.
Yeah, it's fine.
So here is 0.125.
Yeah, it's fine, sir.
Okay. So now find z alpha over 2 for me. We're using 95% confidence interval. What is our z alpha over 2? So it's 95 divided by 100. Then 1 minus 0.95. Then you got 0.05. Then you divide it by 2. You get 0.025. So it's z of 0.025. What is the answer there? Do you have a table? So you can find the table. I think there is a table on the lecture notes, isn't it? Table 8A. So you are going to check table 8A. You check column 1, 2, 3, 4th column, where there is 0.025, and you take the last value there for that column, which is corresponding to infinity, and the answer is 1.960. 1.960. That is your z alpha over 2. Okay. So therefore, x bar n is equal to what? 0,271 plus or minus z alpha over 2 is what? 1,960. Then you multiply by the square root of what? 0,125. Okay, tell me the answer. For this one, it's going to be 0,271 plus or minus what? 1,960 multiplied by the square root of 0,125 is what? The square root of 0,125 multiplied by 1,960.
0,693.
0,693, ne? 0,693
Yes.
to 3 decimal. Yeah, that is the one. Then later, you have to find what again? 0,271. Then you said minus 0,693, 0,271 plus 0,693. Confidence interval. What is the answer?
Sir,
Yes.
I want to ask, yes, because yourself, when you're doing these questions, it seems like you're rounding off. Yeah,
Hey, I'm writing. We have to run them off, of
I
course.
want to know, even us, when we write the test, are we going to round off at any
Yes,
stage?
but round off the final answer to 3 decimal places.
Only the final answer.
Yeah, so that you can get the correct one. You are allowed to round off the final answer to 3 decimal numbers
Sir,
to minimize error.
for the 95 confidence interval, you said it's 1,960. Isn't that for 5%?
You are saying is it for
Isn't it for 5%?
5%?
We are looking for 2,5, right? Z of 2,5.
Z for 2,5.
Is this the value for Z for 2,5? 1,960.
Let me check. Let me check the table there. For 0,025. Why are you saying for 2,5? How do we find them? Z alpha over 2 for 95%.
So I was asking, is the value correct, or we suppose the one for the Z of 2,0,025?
This is the one. Z for 0,025 is 1,960. It's what we got in there.
Okay, okay, sure.
Mm. Do you have a table?
I wanted to confirm, say no, it's alpha divided by 2. Because when I search on the internet, they just give this value, but I don't know if it's for as 0.05 or 0.025.
Uh-uh. It's for 0.025. For
Okay.
0.05, it's I think it's there. It's 1,645.
Okay, thank you.
Yeah, you can check the table. So I'm waiting for the answers there. 0.271 minus 0.693 is what?
What?
0.693.
Negative 0.422.
Yeah, 0, minus ne? 422.
Yes, it's negative
Then
and to our power
the next one,
0.964.
0.964. Okay. So that is our answer. We construct the 95% confidence interval for the mean. Now, number B, it says the data computable with the hypothesis that mu equal to 0. Number B, it says the data computable with the hypothesis that mu equal to 0. We'll find the answer from this, from the one that we've calculated there. If you check the interval here, this interval, can you tell me whether 0 is included or not? In that
It's
interval, is
included.
0 included?
It's included.
So, since 0 is included, so the data is computable with the hypothesis mu equal to 0. So that is the answer, since 0 is included on the interval. Just write it like this. Since 0 is included in the interval, okay, therefore the data is, or if there are many, the data are computable with the hypothesis that mu equal to 0. You get that? Since here our 0 is included in the interval, so the data are computable with the hypothesis mu equal to 0. Full stop. So the question, it says construct the 95% confidence interval. This is what we did. Okay. Then later it says, are the data computable with the hypothesis mu equal to 0? To check that, you go back to the interval and check whether 0 is included. If 0 is included, so the data is computable. Okay. If 0 is not included, so the data is not computable. You get that? So now I want you to go and do this one for me, exercise 5.4.1. Exercise 5.4.1. Can I write it down? You're done here. Can I go to the next page?
Yes, you can
Okay.
continue.
Okay. So now let's go to this exercise for you to do it. Exercise 5.41. Okay. It says, let's suppose you have been given, suppose that in a sample of size 100 from moving average of order 1, which is given by xt equal to zt plus theta 1 zt minus 1 with mean mu, okay, and then theta is equal to minus 0.6, and then sigma squared z is equal to 1. Then we obtain the sample mean of 0.157. The question says, number A, construct an approximately 95% confidence interval for the population mean. That's number one. Number B are the data computable with the hypothesis that mu equal to 0. So just do that one for me. While you are still thinking about this one, you will remember that last time I gave you an exercise on how to estimate the what you call the estimated parameters using least square estimators. Have you done that? Have you tried that one? You didn't? So I can't give you the answer then.
We did, sir. We did.
You
We
did. I
did.
need the answers. Phi 1 is what?
I'm still looking.
I said estimate phi 1 and phi 2. So I need the answers so that I can compare with mine.
Right, okay. Sir,
Yeah.
you mean that exercise from last week
Yes.
where you gave us two equations by way yeah, you gave us two equations. Okay, can I try? I don't know if it's right or
Yes.
not.
Yes.
Uh,
Just come.
for phi one of the first equation for what is it? Is it the armor of one? Yeah, it was armor of one. I mean, what is it? Autoregressive of one. Yeah, that was it. It's what's that one? Is the summation of xt multiplied by xt minus 1 divided by the summation of xt minus 1 squared. That's what I saw.
That is your what? So if I want,
Yeah, for the first equation.
everyone agree with him? Do you agree with him?
We didn't do it, sir.
Anyone?
We didn't do it, sir. Next week.
Okay, let me just give you mine so that you can compare. Yours was what? Can you please tell me so that I can write it down here? It's what? Phi one estimate equal to what?
The summation of
You are
x.
having summations. Just
This is the
convert them
summation.
to the estimated auto correlations. Convert them to this one, rho 1. You know that is equal to gamma 1 over gamma 0, isn't it? Can you be
Yeah.
able to, yeah, convert it to this one? You know that rho 2, sorry, rho 2 estimate is equal to gamma 2 estimate over gamma 0. Can you convert to this? Where you have got, this one is summation of something, and this one is summation of something all square. summation of something all squared, which is going to give you this one. I just want to see whether you got the same answer as mine. Let me just write it here. Remember gamma 1, okay, it's equal to 1 over n summation of can be xt x bar xt plus 1 minus x bar, isn't it? So, but here I think you are going to have something like this. At the end, I don't know whether you have it. Let me just give you phi 1 estimate. That's the final answer. 1 estimate in brackets 1 minus rho 2 estimate. Then you divide it by what? 1 minus rho 1 estimate squared. Think so? That is phi 1 estimate. So, and phi 2 estimate, this is what I got. Rho 2 minus rho 1 estimate, remember? Square divided by 1 minus rho 1 estimate square. Now this is what I got. I don't know, did you get the same answers?
No, I didn't get the same answer, Sesh. I didn't.
And then there, let me just give you gamma 1 or maybe rho 1 estimate equal to, you know, that is gamma 1 estimate over gamma 0. Okay, so which is the same as if you have something like this, xt minus 1 minus x bar xt minus 2 minus x bar. Okay, we take it as a gamma what? It's gamma 1, this one, divided by gamma 0 summation xt minus 2 minus x bar all squared. So it's like gamma 1 over gamma 0. It look like this one, which is different from this one, but the pattern is almost common. It's the same. So I wanted to find out from you, did you get your gamma 1 estimate as this one? Do you have something like this in your
No,
calculator?
sir. No, sir.
You don't have?
Like that.
Yeah.
Oh, wow.
How did you calculate those things now?
Yeah, I didn't calculate it in the same way as yours, sir. So I'm like, okay.
Or you use another approach,
Yeah.
but you're supposed to arrive on the same thing.
I see some.
So yours is what? Can you write it, can you tell me so that I can write it down and try to analyze it if you have it?
I told you for my what's that? Phi 1 is was that phi? Yeah, it's what did I say? I said it's the summation of xt
Summation of xt
multiplied by xt minus 1.
like this.
And then I was like, I gotta use the least squared estimate.
Which you guys, which one are you using? There are two things that I gave you here.
So which one must
Did I
we
give
use?
you this? Let me just write down. Maybe we're discussing about
Something.
different things here.
Yeah.
Let me just write it down. Maybe you'll recall. Who is it?
No.
Okay. It's an autoregressive of order 2, the one that we are talking about. Or autoregressive of order 1.
Order 1.
Oh, yeah, I can see. We are talking about two different things.
Yeah.
So I gave you this one, AR1, which is xt by 1 xt minus 1 plus zt. This is the one.
Now you gave us Taiwan XT plus ZT.
Is
Number
it
one.
not like this one?
No.
Where
This,
I said find myself, I can't even find it. But you were using least square or MME?
I was using least square, but that autoregressive one, it was XT equals to phi 1 XT, not XT minus 1.
Or minus ZT?
No, it was phi 1 XT plus ZT.
Okay, you are referring to this one. XT is equal to phi 1 XT
XT, yes, plus
plus
ZT.
ZT.
Yes.
This is the one.
Yeah, I was
Oh,
referring to that.
okay. So now, what is your phi 1 estimate? Because you want to find this thing.
Yeah, where is it? It was the one I gave you. This one on top. I'm not done with that. It was that one divided by this summation of xt minus 1 squared.
You're not yet done.
No, you see that one you wrote at the top corner, top left corner.
Oh,
Yeah, you divide it.
yeah. If that is the one, yeah. So you are right. This is supposed to
Okay.
be like this.
Yeah,
So it's
divide.
divided by what?
Summation of xt minus 1 squared. Xt
Like this.
minus 1. No, the squared is outside.
Outside
There's
the
a,
xt.
yes, the xt minus 1.
Okay, you're saying you got phi 1 estimate, isn't it?
Yeah, as
Summation
of
xt
xt multiplied by xt
t
minus
minus
1
divided by
divided by
summation.
summation open brackets xt minus 1.
Like this.
Yeah, that's what I got.
Oh, yeah. No, it's okay. Even
Okay.
here, if you can write it like this one, it's the same thing. Yeah. If you can
Yeah,
just say summation of xt minus 1 squared, it's the same thing. Because it's
really?
one thing, isn't it?
Hey, I didn't know.
You know, it's the same
No.
thing. Xt, it's xt minus 1. It's one variable.
Yeah.
So when you square it, you are squaring that variable.
Oh.
So
Yeah, I
isn't
didn't
it
know. So
if you
no.
are having xt, that is a variable, isn't it? So if
Yeah.
you square it, you're squaring it. Even if you do it like this, it's the same thing.
Okay.
It's just because of this estimate, this yeah, but this one is it's correct. It's fine. It's fine. That one. Oh, that is the one that I gave you.
Yeah.
So I was talking something different then. What
Yeah,
is
you were
another
saying
exercise that I gave you?
you are
Which
like
one?
XT. It was the autoregressive of autoregressive 2, AR2.
Autoregressive of order 2.
Yeah, where phi it's xt equals to phi 1 xt minus 1 plus phi 2 xt minus 2 plus zt.
Come again.
Xt
Mm.
equals to phi 1 xt minus 1 plus phi 2 xt minus 2 plus zt.
Okay. So I think I'm trying to check where I got it from. Because here I'm having different thing. Okay, I think I gave you the wrong one. So just try this one.
Which one?
Because that one that you are referring to, I can't even see it. I thought maybe I gave you this one. That is the one that I was referring to. This one, which says xt minus x bar. Okay,
Yeah.
it's equal to phi 1 at, I think it's xt minus 1 minus x bar plus phi 2 xt minus 2 minus x bar. See now? Bar, okay, plus zt. You don't have this?
No, I don't have it. This is the first time I see it.
Oh.
How do you do that one?
Then find. I thought maybe I gave you this one. Sorry.
Oh, you didn't give us this one.
Find the estimates. So this is the one that I was referring to.
Oh,
Okay. Using.
yo.
Is it complicated?
Yeah, I've never. Yeah, it's complicated. I'm looking at the X bar. I'm not even sure where I'm gonna start. I'm not even sure where I'm gonna start.
Method.
Nah,
Yeah, this is
I
the
don't
one that
even
I
know.
was referring to. So autoregressive of order
Oh,
2, like that. So for this one, I can give you the hint.
yeah.
Can give you the hint. Okay, hint. Isn't that you're going to find the sum, isn't it? The sum of
Yeah, of
is
ZT
it how many
squared.
parameters? 2, 3. Is
Yeah,
it 2
there's
or
two.
3? 2.
There's X bar, Phi 1, Phi 2.
Mm. The 3.
Yo,
Yeah, this one is complicated. I wonder whether you will make it.
yeah, I don't think I'll make it. Unless you can give me step by step, then you shouldn't
But
be hard
anyway,
to do.
for X bar, it's already there, so you don't have to worry about it. So you have to find
Okay.
the sum of phi 1 and phi 2. Phi 2.
Okay.
I think they are estimate here. Okay. Phi 1 and phi 2. That is the sum. This one. Then later, so you know how to find it, isn't it? Then you find
Yeah.
the difference, the derivative, sorry, by
With
1
respect to each.
with respect to phi 1 first.
Okay.
Okay, with respect to phi 1 estimate first, then you equate it to 0. Okay, that's number 1. Number 2, okay, number 2, you have to find the derivative again. Let me just use another color so that I can.
With
You have to
respect to
find,
phi 2.
yeah, phi 1. There are estimates there. I think you will see phi 2 estimate with respect to phi 2. So you're going to get another equation. So obviously you're going to get 2 equations.
Okay.
Then later, let me just give you the hint for gammas. I was saying that if you can find something like this, summation of, obviously you're supposed to get something like this, x t minus x bar, okay?
Yeah.
Then x t minus 1 minus x bar, okay? Then you divide it by summation of xt minus 1 minus x bar all squared. Sorry, all squared. So if you find something like this, you must know that this one, the first one, this one is gamma 1 estimate, and this one is what? Is gamma 0 estimate, and it's taking you to what? The 1 estimate.
What is it
So
called, sir?
summation of xt minus x bar, xt minus 1 minus x bar is gamma 1 estimate
Yeah.
divided by summation of xt
Gamma 0.
minus 1 minus x bar all squared is gamma 0 estimate, and they are equal to rho 1 estimate.
Okay.
Yes. The same applies to, I'm just giving you this one because I know that you have to find them anyway. I don't have a space. Let me just go there. Another one is summation of xt minus 2 minus x bar. Okay. And then what? Xt minus 1 minus x bar. Actually, we're supposed to start with this one, but doesn't change anything. It's the same thing. And summation of xt minus 1 x bar. So you can take this one that side or this one that side. It's the same thing. Then it's
Okay.
squared. So if you find something like this, you must know that is what? It's gamma
2.
1 estimate.
Is it gamma,
It's gamma
gamma
1.
1?
Check the yes. Check this one.
Oh, like the T or the XTs. I see that.
Yes,
Yeah.
check this one. Takes you to
This one
gamma
minus this
1.
one.
Then
Oh,
gamma what?
but
Gamma 0 estimate. So again, it takes you to what? Rho 1 estimate. Those are
rose
another things
1.
that you're going to find out. And then the one that I was referring to is this one again. Summation xt minus 1 minus x bar. Xt minus 2 minus x bar. If you can get something like this again, summation xt minus 2 minus x bar. Okay. So this one again is taking you to what? Gamma 1 estimate, isn't
1.
it?
Yeah.
Yes, gamma what? 0. And again, this one is the same as this, if you find something like that.
So, sir,
And the last, yeah?
You see the denominator.
Hey,
So even if it's xt minus 3, xt minus 4, it's still gamma 0.
yes, that's true. Because what we normally check, what type of gamma are we going to have? You check this one and this one. I told you that you take this one, t minus 1, then you subtract the other one, this one, which is t what? T minus 2, isn't it?
Minus,
So it's going to take you
yeah,
to t minus 1 minus t minus 1
plus,
minus t
I mean minus,
plus
plus
2,
2.
isn't it? So
Yeah,
t minus t is 0, isn't it? 2 minus 1, you are left with 1. So that
it's
is why we
1.
are having gamma 1 there. So that is the strategy. The same applies here, it's the same thing. T minus 2 minus this one, t minus 1, okay, which is t minus 2,
It's
is
negative
t minus
1.
t is 0, 2 minus 2 plus 1, you are going to have minus 1. And according to the
Yeah,
properties of autocovariance, is the same as 1. This one. So
1.
therefore you have
0.
gamma 1. So this is how you check the autocovariance. I think we can stop here. So just go and
I
try it.
guess
However, if you find it difficult, we can't do it. It's too long. So we can just leave it out.
I'll come to your office and consult then if I find it
Okay, it's
difficult.
fine.
What number? What office number? What's your office number?
Second floor, Mass Building, Office 2004D.
Okay, 2002
4D, yeah.
2004.
That's where I am.
Okay.
So when are you going to consult? Because tomorrow you are writing.
I don't know, maybe after tomorrow's class.
Yeah.
I mean tomorrow's test. Maybe after tomorrow's
Yeah.
test.
Okay, it's fine.
Before Friday. Before Friday.
Okay, it's fine then. Okay, let's stop here, guys. And then we have covered chapter 1, 2, 3, 4, 5 so far. And then we're left with 2 chapters, chapter 6 and chapter 7. If you can be able to cover them, so they're going to be there on the test number 2. If you can't cover them, they're going to be there in the exam. So obvious chapter 6 and 7, they're very important as well. So we are almost there. Any question?
Are we having a tutorial today?
No. You don't have tutorial. Isn't that you're preparing for test?
Oh, says your test difficult.
No, it's not difficult. It's very easy. You can get total.
Really?
Simple as that.
I want to see it.
Yeah.